Hello everyone. Today we're going to be looking at factoring and specifically on cubic functions. So quick review, when we're factoring quadratics, we have a function in the form y equals ax squared plus bx plus c. This is a standard form quadratic, and quadratic just means exponent 2. Two ways to factor this. We have the sum product rule, where we look for the product of a and c and two numbers that multiply to that, and then the sum of b and two numbers that add to that. We won't review that because there's another video on it and we covered this mostly in last year's math. But we also have the quadratic formula, right? So those are two ways to factor a quadratic formula. Let's look at cubic functions now, right? So a cubic function is similar, but instead of our largest degree being 2, now it's 3. So it's now in the form bx squared plus cx plus d, okay? So we have a new variable and it's x to the 3. How do we factor one of these? Well, it's not as straightforward as it was before, okay? The first thing you always want to look for is to see if you can factor by grouping. What do I mean by that? Well, factoring by grouping is similar to what we did last year, but let's take a look. So x to the 3 plus 3x squared plus, let's do minus 6x minus 18. Okay, let's say we're given this function, we're told to factor it. Well, to factor by grouping, we first want to look at the first two terms and see if they share anything. In this case, you can see that both of these share an x squared in them. So we're going to factor it out. X squared, what's left here? Well, we have x left. And then here, what's left? We have a 3. Okay? And then over here, we're going to do the exact same thing, where we're going to find their largest common factor, and we can see it's negative 6. So we're going to factor out negative 6, and what's left? We have x plus 3. Okay, now we have two terms, right? X squared times x plus 3 and negative 6 times x plus 3. So we're going to factor this out. X squared minus 6 times x plus 3, right? And here we have our final factored product. So we can find our roots from here. Looking at this, you might say, oh, it's a difference of squares, but we can't square root this, so it's not. This would be our simplest version, right? If this had yielded us the answer, something like x squared minus 9 times x plus 3, then we can say, okay, we have a difference of squares, and further factor this to x plus 3, x minus 3 times x plus 3, right? But when we have x squared minus 6, we're going to just find our roots here. So the way we do that, we take whatever's in the brackets and we equate it to 0. So first we do x squared minus 6. What value of x will give us 0? So x squared has to be equal to 6. So x is going to be equal to plus or minus the square root of 6. Okay? And then over here, we have x plus 3 must be equal to 0. So x must be equal to negative 3. And we just found our roots, right? There's 3 of them. One root is at the positive square root of 6, one is at the negative square root of 6, and one is at negative 3. Okay? So here's how we factor by grouping. It's the first thing you should look for anytime you see a cubic function. Okay? That won't always be the case, though. Sometimes we have to do a different method. Okay? And I'm going to give you an example of that. So let's say we're given the function y equals x to the 3 minus 4x squared minus 7x plus 10. So this is an example of a function where you can't factor by grouping, right? Because look what happens if we try. Biggest common factor here is x squared. And then what are we left with? X minus 4. And then here, our biggest common factor, we can't do it, right? There's no common factor between negative 7x and 10. So in this case, we have to find a root first. The way we find a root is instead of looking at this as y, we're going to do as f of x just to make things a little bit easier to understand. Okay, we want to find an x value that makes this function equal to 0. Okay, and there's quite a bit of guess and check into this, but it's guided guess and check. The numbers have to be factors of your d value divided by your a value. Okay, so what are our factors of our d value? Well, d is 10. So we have factors of 10 are 10 and 1, 5 and 2, and that's it. Okay. Our a value, which is the coefficient leading x to the 3, is 1. And our factors of 1 are just 1. So one of these numbers, d over a, so 10 over 1, or 1 over 1, or 5 over 1, or 2 over 1. One of these numbers is going to have to be equal to our 0, right? And it can be plus or minus for any of them. Okay? So the goal here is to fill them in to the formula and see which function gives you f of x equals 0. Okay? Just to save us some time, I'm going to go ahead and give us the answer where the first one is going to be 1. F of 1 will give us 0. Okay, and let's confirm this. Well, 1 to the power of 3 is 1, minus 4 times 1 squared, minus 7 times 1, plus 10. So we have 1 minus 4 minus 7 plus 10. 1 minus 4 is negative 3, negative 3 minus 7 is negative 10, plus 10 is 0. So we've just confirmed f of 1 is equal to 0. What does that mean for our formula, though? Well, that means we can factor out an x minus 1. Okay? We know when x is 1, we're going to have a root in this function. So what do we do now? X minus 1 times what, right? We can't easily see what we need to factor out of this. So my favorite way to solve these is synthetic division. We'll also learn long division, but synthetic division is quite a bit easier to set up. Okay? For synthetic division, we take our function that we started with, okay, and we take all of its a, b, c, and d values. So here, a equals 1, b equals negative 4, c equals negative 7, and d equals 10. Okay? And we know our root is 1, right? The number 1 gives us a 0. So let's set up our synthetic division chart, which looks something like this, and we just line up all our coefficients. So we bring a down here, we bring b here, c here, and d here. Okay? Now, it's pretty simple. The 1 automatically comes down, okay? And then we have to multiply the 1 by whatever number's up here. So 1 times 1 in this case is just going to be 1, right? And now we have negative 4 plus 1. Cool? And we add these numbers. Negative 4 plus 1 is negative 3. Okay? And now we have the number back down here. Once it's down here, we need to multiply again. So negative 3 times 1 is going to give us negative 3, right? So we have negative 7 plus negative 3, or just negative 7 minus 3, which is negative 10. Cool? Then negative 10 times 1, we have negative 10 over here, and 10 minus 10 is equal to 0. This tab over here is specifically important because it'll give us our remainder. Sometimes you won't have a clean division, right? But in this case, we do. We know when we divide by 1, we're going to get a remainder of 0. What do these numbers mean, though, right? Well, now we can put in quadratic formula, or quadratic formation, right? Where this 1 means we have a root at x minus 1. And then this just gave us our a, b, and c value for our quadratic, right? Where it's x squared minus 3x minus 10. Cool. If you notice, if you expand this, it'll re-expand to our parent function over here, right? So we just figured out one root. Now that we have this one root, we can further factor this, okay? I don't see a number that'll obviously work in the sum product rule, so we would go in and do the quadratic formula here, okay? Or would it? Oh no, minus 5 and plus 2 will work here, right? So minus 5 times 2 is negative 10, and minus 5 plus 2 is equal to negative 3. So yes, that'll work. X minus 5, x plus 2 is what this factors into. And then we have x minus 1. And just like that, we have fully factored our cubic function. This is going to be the way you factor your cubic function most of the time. But in the next video, we're also going to cover long division of cubic functions, right? One important thing is when we're drawing this, we're going to have to label our roots, right? So a function to the exponent 3 is allowed to have up to 3 roots, okay? So where are our roots going to be? Well, we know one is going to be at negative 2 because of x plus 2. So negative 2 will be right here. And we know one is going to be at 5 and one is going to be at 1. So 1 is at 1 and 2, 3, 4, 5. Okay? 3 roots to this function. We're going to learn more about roots and sorry, exponents and how they look and their functions and so on and so forth. But generally, if it's a positive function, it's going to start down here and end up here. So what does that mean? It's going to start from the bottom. It's going to have to go through this root, come back down, and then go back up. So generally, you can solve this equation to look something like this, okay? And we're mostly interested in its roots at this point. All right, hope that was helpful. Good luck.